Unit 6, Day 3. We've done sequences. Sequences was the set of numbers. We've done those already. Today we're going to focus on the sum. So we're going to focus on adding them up. So rather than just a list of numbers and finding the terms and finding a formula for the terms, today we're going to focus on the series, which is a sum of numbers. We're going to add them up. And the first thing we need to talk about is a fun pair of words that rhyme. Summation notation. Just kind of fun to say. Summation notation. I guess let's back up and remind ourselves what a series looks like. 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21. And we'll stop there. And if we stop, that means it's a finite sum. If we put the plus ... that would mean infinite sum, and also wouldn't have a sum. So let's stop there because we could actually add those numbers up. But rather than writing it out like that, because that gets tedious and boring and time consuming, we could rewrite that as a summation. That's a Greek letter S. It's a sigma. It's a capital S in Greek. And the S stands for sum. Now here's the pieces. There's more pieces to that, but that's sort of the main piece. And then around that, we'll say n equals 1 to 8. Of 3n. So let's talk about what these things are. N is called the index. And frequently we use I or J or K as the index. So it doesn't matter what number you use, but N is common, I, J, and K are common. I don't think anything else is common, but you could use whatever you wanted down there. So that's like the index, that's sort of the counter that keeps track with how many terms we have. Whatever number is next to the n, that's the lower limit. That leads to the first term. That's the number we plug in first to get the first term. So we like it when it's 1 because that sort of makes sense. Start with 1. It gets tricky if it's not 1, but it's still the first number you plug in, regardless of what number it is. That's the lower limit. The top number is the upper limit. It's nice when math makes sense. The lower number's on the bottom, the upper number's on the top. So we go from n equals 1 to n equals 8. So this leads to the last term. Not necessarily the 8th term, depending on where we started. So it's really convenient when we start at 1, because then things make sense. If we don't start at 1, we have to be super careful. And this thing in the middle here has a fancy name called the summand. It's what we're adding. That's the sum part of the word. But more importantly, it's the formula for an. So it's the formula that we'll use to find all the terms. Here's how we would say that. The sum from n equals 1 to 8 of 3n. how we would read that. So the big E thing, again, it's an S, although it looks like a English E. The big S is the sum from 1 to 8 of 3n. That's how we would read it. So let's expand n equals 3 to 8 of 1 over n minus 2. Expand meaning we don't actually have to add it, we just want to write it out. Write out the pieces. So n equals 3 is what we'll plug in first. And then we'll plug in 4 and 5 and 6 and 7 and 8. And we'll add those all up. I mean, we're not actually going to add them up, we're just going to expand. So if I plug in 3, I get 1 over 3 minus 2 is 1. And again, I'm not starting at 1, so this is a little bit weird, but whatever the bottom number is what you start with. So plug in 3, plug in 4, 1 over 2, plug in 5, 5 minus 2 is 3. Pretty soon you start to see a pattern on these, I hope. Yeah, the bottom's just going up by 1. 1 over 4, 1 over 5, 1 over 6. And again, expand just means expand. We don't actually have to add those. That would be a pain, especially without a calculator. Common denominators, just expand. So if we needed to add all those numbers, it would be a lot easier to use the summation notation rather than writing them all out. Certainly if we had a lot more terms, it would be nicer to do it that way. All right, let's go the other way. Let's write, I'm going to give the expanded form, and we want to condense it into sigma notation. 9 plus 3 minus 3 minus 9 minus 15 minus 27 as summation notation, to be technically correct.
That's one of the sigma sign.
What's that?
That's when you have to change it to the sigma sign.
So that means we want to use the sigma sign. So big sigma, we know we're going to use that. We get to pick which n we want to start with. So what do you think would be the best starting? If you have this pick, you should always pick this. Let's pick 1. So we'll start with 1. And we'll go to 6, because there's 6 terms there. So 1 to 6. But then I need an equation for what's going on in here. So sort of off to the side, I need to figure out an equation that would give me those numbers. This is what we did yesterday and the day before. So the formula for, we should have started with that warm-up or the Kahoot quiz again. A1 plus D times n minus 1. So 9 plus, what's the common difference on those? Not on the ends, but on the actual terms. 6 negative, yes, negative 6, because we're going down by 6. So negative 6 times n minus 1. And here again, this is an acceptable way to write this. Some people are going to distribute that negative 6 so that they get 15 minus 6n. Move my face out of the way. So I need to put this formula for the nth term right here, 15 minus 6n. And then that's the answer. And you could check it, like if we plugged in 6, we should get 27, or negative 27. 15 minus, I plug in 6, 36. 15 minus 36, that doesn't equal negative 27, does it?
21.
What did I do wrong? Oh, I wrote down the wrong number. That's why. Like, wait a minute.
On the very first thing, you supposed to talk 8 terms and only 7 terms.
Wait, what's that again?
The very first thing we did.
This one?
The first ever time that,
Oh, way up here. 1, 2, 3, 4, 5, 6, 7. Yep.
Oh.
I can't count. No wonder you're looking confused. Like, wait a minute, what happened here?
So that means the one below it. Wait.
But this one's still right, because I wrote it all out, so I didn't mess this one up. 3, 4, 5, 6, 7, 8. So we started with 3, we ended at 8. This illustrates a good point that I didn't mean to make, but I've accidentally made now. When you write them out carefully, you're more likely to catch a mistake like that. 1, 2, 3, 4, 5, 6. So from 1 to 6. And I caught that mistake because I was checking to see if that last term worked. 15 minus 36 is negative 21, which is what my last term was. So I feel good about my answer now. Accidentally messing up to illustrate why we check our work. Let's do another one. 400 plus 200 plus 100 plus 50 plus 25 plus 25 over 2. We can stop there. The notes I have goes on further. I'm like, oh, we can stop there. Exactly. But that's why I messed it up. I keep shortening these. So you said divide by 2. So that's a good thing to notice. So what's that mean?
It means it's geometric.
It means it's geometric, which means it has an r. So what's r equal to? Right, 1/2. Remember, it's not r equals divide by 2. It's r equals 1/2. What we're aiming for, though, is this summation thing. From n equals, again, I think it's best to start at 1 if you have the choice. 1, 2, 3, 4, 5, 6. Now I'm going to be super careful to count them correctly. So from 1 to 6. And then what goes in there is the formula. So good reminder of the geometric formula. A1 times r to the n minus 1. So 400 times 1/2 to the n minus 1. Can't really simplify that, so 400 times 1/2 to the n minus 1. Example 4. This one's going to illustrate something. Sum from n equals 1 to 20 of 7n plus 2. Roman numeral 2. The sum from n equals 0 to 19 of 7n plus 9. 7n plus 9, not 19. Here we go. 7n plus 9. Much better. And Roman numeral 3, the sum from n equals 2 to 21 of 7n minus 5.
It's the same problem.
Is it? So Tyler says it's the same problem, and now he's backing off that assertion. Let's make some comparison here.
Oh no, we're comparing.
Yeah, we're comparing. So
It was like one problem with different steps.
let's convince ourselves if these are the same or not, because like something similar going on here.
I mean, they all have 7 in.
They all have a 7n, so that means you're jumping ahead of me here, but that's okay. That means they're all arithmetic with D equals 7.
It's just where they start, and then
So
everything between.
So maybe they're the same. How many terms does this first one have? This is the easy one.
1.
If we go from 1 to 20, if we start counting at 1 and we go to 20, that's 20 terms.
Wait a second.
Now, counting when we don't start at 1 is where things get a little bit tricky.
That's also 20.
If we start at 0 and go to 19, how many numbers is that? 20. Like 1 through 19, but then we add 0 in there. Or if you really want to be crazy, you'd count from 0 to 19 like on your fingers, but your fingers are doing the counting. That's almost more confusing than it's worth. There's 20 terms there. How about that last one? If we count from 2 to 21, right, it's like, it's really hard to count and put your fingers at a different spot. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. How many fingers did I go through? 20. Maybe a better way to do that. 21 minus 2 is 19, but then you got to remember you started counting with 2. So don't forget to include the 2. There's 20 terms in there. So we're starting to think, hey, these might actually be the same thing. How about the first term? If I plug in, the first term would be plugging in 1. So what would I get for the first term? 9. On the second one, to get the first term, what do I plug in? 0, because we're starting with 0. So be careful. The first term is n equals 0, which we get 9. Well, that's because I wrote the wrong thing down first. 7n plus 9. On the third one, the first term, but we start at 2 this time, so we plug in 2. 14 minus 5 is 9. So they all start at the same spot. Well, if they start at the same spot, they have the same difference, and they have the same number of terms, I'm convinced that they're the same. If you want to check the last term, we'd plug in the top number, and we get 142 for all of them. Just speed it up a little bit here. We're arguing over how to count. That's why it's nice to start with n equals 1, because then the top number is how many terms you have. If you don't start with 1, you have to be super careful about how many terms there are.
Can you explain that part?
I mean, I can explain it, but it's really just...
Do you have to add something else to it?
Maybe a better way to think of it is if you started with 1 and went to 21, that'd be 21 numbers. But we're not including 1. We started at 2. So we're down to 20 terms. There's not a formula for it. You have to be able to think about it and figure out, wait a minute, it's whack. It's fair. That's why when you get the choice, you almost always start at 1, because then it works out. If it doesn't start at 1, you got to slow way down and figure out what the heck is going on here. All right, well, I don't really want to add those up. Like, I don't want to type them all out and add them up. Well, it turns out there's a shortcut formula. So some shortcut formulas. For arithmetic, S sub n, and we'll talk about what these mean. The sum of the first n terms, that's the S and the n. And then here's the formula. N times a1 plus an all over 2. So you don't have to write out all the terms and then add them up. I mean, you could. And people who forget the formula, which you're not going to because we're going to give you the formula. But in years that we don't give you the formula, there's always some people that write out all the terms because they forget the formula. It takes them a while, and they have to be careful, but they can get there. This is much easier. S of n, sum of the first n terms. N is the number of terms. A1 is the first term. AN be the last term. And I guess I would say A1 is the most worrisome of the group because you don't necessarily plug in 1. You plug in whatever the first term is, or the first index number is. So you think back to that last example where we were comparing these. The first term was always 9, but one time we plugged in 1, one time we plugged in 0, one time we plugged in 2. But the first term was always 9. So again, the trick comes if you don't start with 1, you got to be real careful with who the first term is. Plug in the lower limit, that'll get you the first term. Plug in the upper limit, that'll get you the last term. So let's try this with, just wrote the wrong kind of E. Evaluate the sum from n equals 1 to 100 of 4n plus 3. So there's 100 terms. I could write them all out and add them all up. That would really not be the preferred method here. I'm going to write the formula again just because writing it helps me learn it, even though you will be given it. Also provides the roadmap for what I need to find along the way. So I need to find n, the first term, and the last term. And then I'll be ready to use that formula. So what's n? How many terms are there? I gave you an easy one. If we start counting at 1, there's 100 terms. The first term comes from plugging in the lower limit. So the first term is 7. The last term comes from plugging in the upper limit. So 400 plus 3, 403. So now I'm ready to plug in the pieces. N is 100. 7 plus 403 divided by 2. So without a calculator, let's split this up to make this easy here, or easier anyway. 7 plus 403 would be 410, and 100 over 2 would reduce to 50. And then 410 times 50, or 41 times 5 and stick 2 zeros on, however you want to do that. $20,500. Way easier than writing out 7, 11, 15, 19. Wait, not commas, but pluses. 7 plus 11 plus 15 plus 19. 100 times. I'm grateful someone came up with this formula. And again, it's given on the test, so you'll be okay. You don't have to know how to use it, know what the things stand for, but you don't have to have the formula memorized. All right, for geometric, same story. Nobody wants to memorize, or nobody wants to add up 100 terms by hand. It'd be nice if someone came up with a formula for us, and they have. A1, 1 minus r to the n over 1 minus r. Same stuff here. S sub n is the sum of the first n terms. A1 is the first term. R, what's R stand for? What does R usually stand for when we're dealing with geometric? The common ratio, what we're multiplying by. And then N is still the number of terms. And that will be given as well. So you don't have to memorize it, you do have to know how to use it. So last example, instead of written in I'll write it out this way. Find the sum of the first 6 terms of a geometric series, although I'm being lazy, geo series, with A1 equals 7 and R equals -2. So I'm going to write the formula again, mainly because it helps it stick in my brain, even though I don't have to have it memorized, but also because it's sort of the roadmap for what I need to find. A1, R, N. Now, I kind of go overboard on showing my work on these. The other extreme is to not show anything and to just start plugging in straight into a formula. That's what messes people up, because it's like 2 steps. I got to think of the formula and think what goes there. Slow down. Like, don't mess up because you're trying to not show any work. All right, first term. What's A1? 7. R is -2. What's N? How many terms are we adding? 6 terms. So the sum of the first 6 terms, I should put a 6 down there. I forgot to do that on the last one. I put N, but the sum of the first 6 terms, A1 is 7, 1 minus -2 to the 6th, all over 1 minus -2. Be careful with the signs, because we got negatives all over the place.
No, it stays negative because you have to square it for the 6th.
So 1 minus, what's -2 to the 6th? Have you done 2 to the 6th enough to know what it is? If not, you just count them out. 2 times 2 is 4, times 2 is 8, 16, 32, 64. And it's positive because that's an even power. -2 to an even power is going to be positive. But then this minus is from the minus sign. 1 minus -2 becomes 3. So 7 times -63 over 3. You could multiply first, but I think I want to divide first because that's going to be a lot easier. Because 63 divided by 3, I can do that. That would be -21. And then 21 times 7, old school multiplying, is 147. Negative 147. Be careful with your signs for the geometric one. I mean, all the time, but especially with the geometric, because you got minus, and then if r is negative, you got minus negative, but you're squaring it, so be careful. Be careful. All right, unit, whatever we're in, worksheet 3 is the assignment. Answers are posted. Have a great weekend.